Okay, here we are with 11.2. We're moving into this concept called volume, the three-dimensional space that an object occupies. Oh, there we go. Now I'm all self-conscious about saying Thanks, Gabby. Anyways, we have the volume of prisms. You have three examples here. Here we have triangular bases and this height that it covers. So we're looking at all of the space on the inside here that's occupied. That's what volume means. So you see here the basic formulas. I recommend getting yourself a formula sheet. The rest of this section is going to be all formulas, the rest of this chapter. So here you see, you always want to determine, this is true for every solid for the most part. Determine the area of the base, that's what the B means, and then multiply by the height. So this is like taking a triangle in space, and then you want to drag it down so it ends up here. Well, what does it all cover? I don't know if that made sense to anybody, but we've talked about this before. You want to take the two-dimensional area that it covers and then drag, push it down that third dimension, the height. That's what we're doing. Here you see in the rectangular prism, you take this rectangle and you push it down and it covers all this space inside until it gets to here. So all you need to do is determine the area of the base, which is what? Length times width. That's what this part is. And then multiply by the height. So you're just multiplying three things. Up here, the base of a triangular prism would be 1/2 base times height. Don't get that height and that height confused, but we'll get into that in the examples. Don't worry. A cube, very basic. All these sides are the same length. Every edge is length s, so the volume is just s cubed. Straightforward. Again, determine the area of the base. In this case, it's a cylinder, so it's going to be pi r squared. And you want to multiply it by the height. That's the perpendicular height. Okay, this is called a slanted cylinder. You want this perpendicular height. Still that guy. Area of the circle. Let's take a look at some examples now. We're 3 minutes in. So the volume of a rectangular prism is length times width times height, which is, I just said height, which is 16 times 4 times 9. What does that equal? Simple. Number 2, what's the base? The base is a triangle. Therefore, I know that it has to be 1/2 base times height. This is for the triangle. So this is 7.5. Then we're going to multiply that by the height of the prism, which is 8. 7.5 times 8 is 60. Remember, we're talking about cubic inches, cubic centimeters, cubic millimeters, and cubic feet. The volume of each cylinder. So we want pi r squared, which is the area of the base because it's a circle, times the height. So over here we have pi, the radius is 8 squared, times the height. Well, 8 times 8 is 64, times pi, times 10. You see that we have 640 pi because we want answers in terms of both pi and rounded to the nearest tenth. Over here at number 4, we have the area of the circle, which has to be pi r squared times the perpendicular height. Right? So this is going to be 9 pi times 5, which, once you work it out, is equal to 45 pi. Multiplying by 3.14, you get your answer. Easy peasy. This is what happens when we changed the dimensions. How does it affect proportions? I mentioned this at the end of chapter 10, how in volume everything becomes cubic. Instead of squaring, you're going to be cubic because you have 3 dimensions that are all being changed, so you have to have 3 copies of it, which is exactly what this page says. If you want to hit pause and take a look, have at it. If worse comes to worse, you can always empirically change the dimensions based on what you're doing with the parameter they give you and calculate. But you'll always see that it's going to be the cube of the change. So let's take a look at that. If the dimensions are multiplied by 2, 2 cubed means the whole volume is going to be multiplied by 8. Simple. They don't ask you to calculate the volume. You can, but that's what happens. Over here, the dimensions are multiplied by 1/4. That means they're getting smaller. You should expect something smaller. 1/4 cubed means the volume is multiplied by 1/64. Very easy stuff. Down here, we've got composite figures. So we've got a soda can on top of a box of Frosted Flakes. Calculate the 2 areas individually. These are 2 problems that you add up at the end. So the area of the Frosted Flakes, is 10 times 5 times 3, which is 150. And this is pi r squared times the height, which is 4 times 4 times 4, which is 64. So we need to add 64 pi to 150. We only need to round to the nearest tenth, so something doesn't feel right. I'm going to come back to that. Something doesn't feel right there. Here we have 2 cylinders. Oh, I showed you the answer. Perfect. Well, how do I do this? We're going to do pi r squared for both. So we have pi times 2 squared times 2, and pi times 3 squared times 3. So this is 2 times 2 is 4, times 2 is 8, which is 8 pi. And this is 3 times 3, which is 9, times 3, which is 27 pi. And when you add those up, you get 35 pi, which equals 110 feet squared. Back to this one over here. I did something wrong. 50 times 3 is 150. I'm confident there. Pi r squared h. 2 times 2 is 4. Oh, it's 16. What a butthead. Sorry. So 150 plus 16 pi. 16 times 3 is 48. So this is much better. Sorry. There's your assignment. Good luck. Stay safe.